Welcome back. Today we're going to finish up section 1. Our goal for today is to extend a little bit on our conversation on vectors. Last lesson we focused primarily on the use of Pythagorean theorem and adding vectors together. We talked about some of the vocabulary words such as like the components and the resultants. So what we're going to focus on a little bit more today is kind of making the connection between the magnitude of a resulting vector as well as relating it to the direction. Okay, now what we're going to do today is we're going to focus a little bit on what's called trigonometry. So trigonometry is a study of math that is going to look at the relationship between the sides of a triangle and the angle of the triangle. Now specifically what we're going to look at is the angle and the angles and sides formed within a right triangle. So let's say that I have some resulting vector. And what we talked about last time is that a resulting vector can be broken down into components. So say that this vector is going up and to the right, that it has, let's say, an x component to the right, and part of that vector called the y component goes up straight up. So between those two components, you have your right triangle or your right angle. So again, we make a right triangle. So what trigonometry does is it relates the angles formed between the resultant and each individual component. So I'll label that one in blue, and then we would have the angle here between the resultant and the y component. Now how we're going to symbolize our angles, we're going to use the Greek letter called theta. So it looks like kind of like an Easter egg. It's the Greek letter theta. It's just our symbol to represent the angle, okay? So I have here the blue angle and the green angle, and essentially there's three trigonomic functions. There's what's called the sine, the cosine, and the tangent. For short, you're going to see this as sin, cos, and tan. Cosine, cosine, and tangent. Not sin, cos, and tan, but sine, cosine, and tangent. What it does is it relates the angle of a triangle to two specific sides of a right triangle. And now these the sides that it relates is all dependent on which angle we're choosing, okay? So let's just say I am looking at the blue angle, okay, in my picture here, so the blue angle there. The three sides that you're going to see denoted here is you're going to have first the side across from the angle. This is called the opposite side. You then have the side next to the angle that is not across from the 90. This is called the adjacent side, which is a math word of saying next to. And then lastly, you got the side that's always across from the 90, which is our resultant. This is called the hypotenuse. Okay, so what the trig functions are going to do is it's going to relate the angle to two of those three sides. Okay, and all this is related to is it's related to the idea of a unit circle. So imagine if I were to take this yellow point and kind of rotate it around the circle. What I see is that as the angle starts to get bigger, the opposite side and the adjacent side of this triangle are going to change in length. So if I move this point up to say here, my opposite side, which would be the green line, gets bigger, but my blue line would get smaller. So what happens is that the angle affects the lengths of my components, x and y being my components, all right? All the while my hypotenuse doesn't change. Okay, so our hypotenuse would stay the same, our resultant would be the same no matter what, but what's going to happen is our x and y components are going to vary. So what each of these represent, the sine is going to relate the angle, and it's going to relate the angle to the opposite side and the hypotenuse. Okay, so the opposite side would be the side across from it, so that's the y component in this case. It's going to relate the length of that side to the hypotenuse of the triangle. Okay. The cosine is going to relate the same angle, but now it's going to relate the adjacent side to the hypotenuse. So it's going to say, okay, as that angle changes, what happens to the adjacent side? Now, why we have two functions here is because, like I showed, as your angle changes, this might get bigger or smaller, but let's say that y gets longer. What happens is that the x component gets smaller. So we see kind of an inverse relationship going on between them. So that's why we have two separate functions. Now, the tangent function, that's the one that relates those two sides. So the opposite and adjacent change as one changes, the other changes. So the tangent is going to relate that angle to those two changing sides. So what we're going to do is we're going to use these three trig functions. They're going to relate the angle to the sides. So what is this going to allow us to do? Well, at first, it's going to allow us to do a couple things. It's going to allow us to take a resulting vector and an angle and allow me to find the components in each direction, as well as it'll allow me to find the angle of that vector, which is again going to give me a little bit of indication of the specifics to the direction of what that vector is looking at. Pythagorean theorem, which we used last class, only gave us the magnitude of r, but never gave us anything about the direction other than just a general sense of the direction. So the trig functions will now give us a specific direction. So here's what I mean. So this first example, what we're going to do is use the trig function to find our components. So now this one I'm going to give you the resultant. So here you'll note I give you, let's say, 50 meters per second. This is our resultant vector, and you are given the angle of 60 degrees. Okay, so for every vector that's at an angle, what we're going to get are components. So I'm going to have an x component I'll draw in red, and we're going to have a y component I'll draw in blue. Okay, between every two components is where we have our 90-degree angle. So notice with the angle that you're given here is 60 degrees. The blue component, which is my y, this is going to be, compared to that angle, is the opposite side. I'll write OPP. Okay, the x component, which here is next to my angle, so that is going to be the adjacent side. So if I want to find the lengths of those components, what I can use are my trig functions. So I'll start first if I want to find the y component. So what I'm going to do is I'm going to use my trig function here. If I want to find the opposite side, I'm going to use the trig function of sine. So the sine of my angle 60 degrees is going to equal the ratio of the y value, which I don't know, over the r value, my resultant, which is 50. Okay? Now here's what happens. If I take the sine of 60, what I'm going to get is a decimal. Okay? And the decimal I'm going to get is about 0.87. And that's going to be a rounded value. Now what this means, the best way I like to think about this is as a percent. This means that the y component is going to be 87% of 50. Okay? So if I want to solve for the y component, what I'm going to do is just take that 0.87 and multiply it by the resultant of 50, and that should give me y. So in this case, if I multiply that value by 50, I should get about 43 meters per second in this case. That's going to be how much my y component is going to equal. My x component, I'm going to do the same thing, except I'm going to use a different trig function. So since I'm looking at the adjacent side, I'm going to use the cosine. But again, the cosine is going to relate the same angle, but now it's going to relate to that different side. So here's the idea. If 87% goes towards the y component, we should see a smaller percent going towards the x component. Now, unfortunately, my idea of percentage doesn't work out perfectly in this way. Like we're thinking, okay, 87%, then it must be like 13% that would go towards that. Not ending up how it looks, or that doesn't exactly how it work out. But if I take the cosine of 60, what I'm going to get is, I'm going to get 0.5. Now 0.5 is a percent. Think of this as 50%. So that means 50% of 50 is going to go towards the x component. So by finding that, I'm just going to take 0.5 and multiply it by 50, and that's going to give me my x component. So in this case, my x component is going to equal 25 meters per second. So again, what this is finding is it's finding how much speed I have in each direction. All right, so let's try one more example here, and then I'll have you guys try the last one on your own. So here I have rambunctious Fido is being pulled back with a force of 60 newtons. So the 60 newtons that's given to you guys, that's going to be my resultant vector, shown here by the leash and that arrow. And it's being pulled back at an angle of 60 degrees to the right of the vertical. Now that phrasing right there is a little bit tricky. So to the right of the vertical means this, that if I were to draw up here a vertical line, and I'll go from Fido's collar, that this angle right here is going to be 60 degrees. Okay, now this one's a little bit different because what we're going to do is we're going to break this up. We can break this up different ways. So first of all, if I want to look at it this way, what I'm going to say is, okay, if I'm pulling back that way, I'm pulling a little bit to the right, and then I'm also pulling with a certain amount of force upward. So what I get is my y component again here, and my x component, and anytime we have our two components, between them we have the 90-degree angle. Now the thing is that if I'm pulling with 60 degrees to the right of the vertical, that means this angle right here should be 30 degrees, because I should know that between the vertical and the horizontal is 90 degrees. So if that's 30, what I can do is, just like I did here, I can use my sine and my cosine to find the two components. So I'll start off with y. To find the y, I'm going to take the sine of 30 degrees, and that should equal the amount of y I have. It's going to, again, look at a ratio in terms of 60. So again, sine of 30 is going to be 0.5. So that means 50% of 60 is going to go towards the y direction. So that means your y component is going to be 30 newtons. So as I pull Fido back at that angle, 30 newtons is actually how much I'm pulling up on Fido. Versus the horizontal or x component, I'm going to use the cosine. So I'm going to use the cosine of 30 equals x over 60. Again, the cosine of 30 is going to give me a percent. So in this case, the cosine of 30 is going to give me the same thing that I had before. It's going to be about 87%. Notice that compared to the last example, it's switching. So I'm going to find 87% of 60. So I'm going to take 0.87, multiply it by 60, and that's going to give me the x component. So if I do that, if I multiply 87% again, or 0.87 by 60, that should give me around 52 newtons of force in the x direction. And again, notice here when we look at this, here I have a bigger angle, 60 degrees, so notice that my y component is bigger than my x. 30 degrees here, even though you were given 60, but in terms of our triangle, 30 degrees means that I have more in the horizontal than I do in the vertical. When these two would be exactly the same is when I have a 45-degree angle. So what I'd like for you to do right now is to pause the video and try C. So in C, you are going to try and break that down into its two components. So it says a plane is flying from Chicago at that speed and at that angle above the horizontal. So what would you get for your two components? So pause the video, give that one a shot. All right, so if you take a look, here's what you should get. For the y component, again, using sine of 70, you should get 470 miles per hour. And for the cosine of 70, you should get 171 miles per hour. And again, that is how fast that plane would be going in each of those two directions. So again, we can use the trig functions to find our components. Okay, so we're going to do just one last example. You're trying to make the connection between Pythagorean theorem that we did last time and the trig functions. But in this example, we're going to use the trig functions to actually find the angle or the direction of my resulting vector. So here you have, this is kind of a relative motion problem. So it has a motorboat traveling 4 meters per second east. So let me just draw that. So if I have 4 meters per second east, that would look something like that, encounters a current that is going 3 meters per second north. So I'll draw an arrow up of 3, and that's going north. It's going to form then a resulting vector again by looking at start to finish. That would go from here to there. So that's my resulting vector. So what we're going to do now is we're going to find the overall information about this resulting vector. So our goal, anytime we want to find the resulting vector in total, our goal is to find two things. One, we want to find the magnitude. So the magnitude is, again, how much. But we also want to indicate the direction. So for the direction, we're going to find that Easter egg, that Greek letter theta. Okay? So to find the magnitude, we're going to use Pythagorean theorem. To find the direction, we're going to use our trig functions. So I'm going to start off first with the easy part. I'm going to look at using Pythagorean theorem. I know that if I square the two sides, 4 squared plus 3 squared, and I add them together, that should give me the resultant squared. So if I perform that math, I should get a resulting of 5, and again, this would be 5 meters per second. So using Pythagorean theorem, I can find the overall magnitude. So again, that's how fast the boat would be moving due to its own speed and because of the speed of the current. But also our goal is to find the angle. So when I talk about the angle, I can find either two things. I can look at the angle between R and this, R and 4, so my horizontal component, or I can find the angle between R and 3, my vertical component. In this case, I'm going to find the angle between R and the horizontal component. The reason why I'm going to do this is that on a graph, we always kind of refer our angle to the positive x-axis because this is normally 0 degrees, and we rotate all the way through, it goes all the way up to 360 degrees. So I always like to make all my angles usually reference towards the x-axis. Okay, so I'm going to try and find this angle. Now, I have all these options. I know that R is 5. I know that the horizontal is 4 and 3. So what I got to do is I got to choose one of my trig functions. So let me just choose sine. Okay, so I'm going to choose the sine of my angle relates the opposite to the hypotenuse. So notice when I plug things in, a sine of my angle. First of all, I don't know what my angle is in this case, but I do know that my opposite side is 3 and my hypotenuse in this case is 5. So now here I know the lengths of the sides, but I don't know the angle. Now remember, when you take the sine, cosine, or tangent, you're going to get a decimal, and the way I like to think about it is that that decimal represents a percent. So if I were to divide 3 by 5, that's going to give me a decimal, and I want to think about that as a percent. So when I do that, that's going to give me a decimal of 0.6. So what this means is that the sine of theta should give me 0.6. So what I'm trying to do is think about, okay, what angle would give me that? So to figure that out, what we're going to use is something that's on your calculators, but we are going to do the opposite. Right? We're trying to work in reverse, so that's called an inverse operation. So we're going to do the inverse sine of that value 0.6, which is essentially going to tell my calculator what angle would give me 0.6 when I take the sine of it. So to do this on your calculator, again, you're going to hit that second sine, and you're going to see that inverse pop up. So it's second sine, and then you want to do 0.6 inside, and then what you should get is a nice little angle. And what you should get is about 37 degrees. Again, I'm going to round that to a whole number. Okay, so that means that would be the angle of motion. So I know in total that this would be my resultant vector, that my resultant would be 5 meters per second of speed, and I'll say at 37 degrees, and I could say northeast, I could say above the horizontal, many different ways I can label that, but I'll say at 37 degrees. So what I'm doing now is I'm using the trig functions to find the angle and Pythagorean theorem to find the magnitude. Okay, so I'm going to stop there. I know there's a couple more examples, but we'll do those things in class. But again, this is making the connection between the trig functions and how we're going to use them, as well as Pythagorean theorem. Any questions, make sure you jot them down. Again, a lot of math going on here, so bring those questions to class if you got them.